So this is all about the sum and difference formulas of trigonometric functions. Here they are, and they're not that bad to memorize. And in this video, I'm just going to kind of go over the basics of them and kind of manipulating them to get exact answers. And so for this video anyway, I'm just going to show you about how you can take an angle that you are not familiar with. Some of these, I'm sorry, like if you're thinking of taking the sine of 100, for instance, that doesn't do you very good. But if we can manipulate that into the addition of 2 degrees that we do know the sine of, then we can use these formulas to get an exact answer. So again, in this video, I'm just going to show you really the basics of how to use it, and I'll have another video where we get a little more in depth in it. You will need a unit circle to look at. Hopefully you have it memorized. But if you do all these problems, you'll have most of these memorized. They're actually really not that bad. You just got to watch your signs on them. But I'm going to skip the first couple sections because you're just basically just plugging things in and seeing how they work. And so I'm going to start with number 18. I'm going to work through 18 and 20 and then talk a little bit more about the next section. And that'll be all we do for this section, or for this video. The book goes over the proof of, I believe it's sine, the sum, the sine of u plus v1. It's worth looking at, to see where it came up with. People had to think this through, and all you have to do is just kind of memorize these formulas. So the first one we're going to look at is in degrees, and I think degrees are a little bit easier for these kind of formulas because it's easier for you to think about what combines to get the original. But we're thinking of only degrees that we know of on the unit circle because we're being asked to find exact values, and we only know sine, cosine, tangent, etc. of 30, 45, 60, 90, 120, etc., etc. You will not find 105 on there. There are, I'm sure, several different ways that you can rewrite these. You could probably get them into subtraction one if you wanted to. I'm going to actually do an addition one, and the one that pops out the most obvious for me is if this was negative 60 degrees plus a negative 45 degrees, right? You add those together, you get negative 105. They both show up on the unit circle, so we can find exact values of them, right? So the 315 would be our negative 45, and 300 would be our negative 60. So we're going to end up using the addition one. We're asked for sine, cosine, and tangent, so we're doing these 3. And, we're just plugging things in and evaluating them at this point. So I'll write it out as, the sine of negative 105 is equal to the sine of negative 60 plus negative 45. And it doesn't matter which way you write these, or in which order, I should say. Now I'm just applying the formula here. So this is equivalent to, I'll point out, right, for the way I set it up, and according to the function here, u is negative 60 degrees and v is negative 45 degrees. So then we're just saying that that's the equivalent of sine of negative 60 times cosine of negative 45 plus cosine of negative 60 times sine of negative 45. And right, like I was saying before, it's not really that bad to, I mean, you're just kind of switching them on that, switching them like, sine of u, cosine of v, sine of v. So it's not really a horrible formula to memorize. And now all I'm doing is pulling the x and y values off of the negative 60 and the x and y values off of the negative 45 or 315. Remember that the y values represent, or the sine represents the y values and the cosine represents the x values. So the sine of 60 is the same as negative radical 3 over 2 times the cosine of negative 45 would be square root of 2 over 2. Again, I'm just getting these from the coordinates from the unit circle there. Cosine of negative 60 is 1/2. And sine of negative 45 is negative radical 2 over 2. And now we're just simplifying. So the first one's going to be negative square root of 6 over 4 plus a negative square root of 2 over 4. And for me, this is a good enough answer. You're gonna see that the back of the book has, they're gonna do some factoring. I don't think they do on this one, but they'll do some factoring out. If you get it down into one fraction like that and you've simplified it as far as you can, then that's pretty good for me. If you're not sure if you have the right answer, I guess that can be annoying. So that would be the exact answer for sine of negative 105. And I'm just going to run through the rest of them. So the cosine of negative 105 is the same as cosine of negative 60 plus negative 45. And again, I'm just getting the coordinates off the unit circle now because 60 and 45 are findable. So then the cosine of, let me write it out for you. So then cosine of negative 60 times cosine of negative 45 minus sine of negative 60 and sine of negative 45. And now I'm getting all the coordinates off of it. So the cosine of negative 60 is 1/2. The cosine of negative 45 is radical 2 over 2 minus the sine of negative 60 is negative radical 3 over 2, and the sine of negative 45 is negative radical 2 over 2. We're just simplifying now, so square root of 2 over 4 minus the square root of 6 over 4 and again, this is good for me. They're going to factor out, I think they factor out a radical 2 over 4, and so then the back of the book it would look like it would look like square root of 2 over 4 times 1 minus radical 3. But I don't know that it's necessary to go quite that far. Okay, so then the final one they want us to do is the tangent. So again, this is the statement: tangent of negative 105 equals tangent of negative 60 plus negative 45, and I'm just plugging it into there to the formula. So then that's the tangent of negative 60 plus the tangent of negative 45 over 1 minus the tangent of negative 60 times the tangent of negative 45. Again, if you know them by heart, great. Otherwise, check the unit circle for all of these. And the tangent of negative 60 is negative radical 3 plus the tangent of negative 45 is a negative 1, and that's over 1 minus a negative radical 3 times a negative 1. And so then we would have this. Now be careful, these are not, this answer is not negative 1. We're going to rationalize the denominator, and hopefully you remember that. So we're going to multiply both top and bottom by 1 plus radical 3. I'm going to try to save some space by skipping a little bit of steps, but foiling, make sure you're foiling. The numerator would be negative 1 minus 2 radical 3 minus 3, and that would be over 1 minus 3. And that's what that would simplify to. And then we can simplify by dividing everything by negative 2. So then we would have 2 plus radical 3. And that would be the exact answer for that. So I'm sure there is other ways to get to negative 105. And it doesn't matter which way you choose. That was, as long as, two things are true. Firstly, that the two new angles you come up with do add or subtract to give you the original, and that both of the angles that you choose are actually, that you actually know the exact answers on, okay? So that's all 30 degrees, 45 degrees, 60 degrees, and 90 degrees, and so on along the unit circle. Okay, so I did want to do number 20 as well. We're given this 5 pi over 12. We're asked to find the sine, cosine, and tangent of it. And again, the exact values of them. And you notice that around the unit circle, we don't have anything with a denominator of 12. Okay, all our denominators are either 6, 4, 3, or 2, or there is no denominator. And the challenge on this one is to rewrite this as the sum of a couple of these. Now, the nice thing about this problem, of course, is that 12 is divisible by all of these in here. And you're totally welcome to play around with it until you figure out which one it is. You can just start grabbing pi over 6 and pi over 4, see if you can add those together. You can go on, pi over 4, pi over 3, and you can just keep playing around until you figure out which ones add to give you 5 pi over 12. Sometimes it'll be very straightforward and maybe not a big deal, but other times maybe you can get stuck. So I'm going to show you another option for yourself to go through these, and it's very mathematically done, and it will work. You may not enjoy it as much because we have to do the partial fractions, and this is one of the things that we can do. And so I'm going to use partial fractions, the idea of partial fractions, to find exactly what these two answers are. Again, your other option is to guess and check. So if you remember your partial fraction stuff, I'm going to rewrite this, say 5 pi over 12, and that equals a over 4 plus b over 3, and I'm choosing 4 and 3 because they multiply to give me 12. Okay, now of course I'm going to need two equations because I'm going to have two variables here. So the other equation, right now we're using this set of factors to get to 12. So then the other equation, I will use a different set of factors to get to 12. So, I'm going to say 5 pi over 12 could also equal a over 6 and b over 2. And so now we've created two equations and we have two unknowns. I'm going to solve these at the same time. And the first step is to multiply both sides of each equation by 12. And I'd be left with 5 pi equals 3a plus 4b. In the second equation, I'd be getting 5 pi equals 2a plus 6b. All right, now we're just using system of equation rules to eliminate a's and b's. So I'm going to multiply this first equation by -2. And then I'm going to multiply the second equation by 3, and that way I'll have be able to eliminate the a's. So then we get -10 pi equals -6a minus 8b. And then in the second equation we would have 15 pi equals 6a plus 18b. And so I'm going to rewrite this underneath. So -10 pi and -6a and -8b. And when we add those together, we're going to get 5 pi equals 10b. And when we divide by 10, we get that b equals pi over 2. And we're going to substitute b back into this other equation. So then -10 pi equals -6a minus 4 pi, right? That's simplified. We're going to add 4 pi over and get -6 pi equals -6a. And that means that a is equal to pi. So we found a and b, but we did not find the two things that add together quite yet. So what we're going to do is go back to one of our originals, and I'm going to go back to here I'll just rewrite it here. I'm going to go back to 5 pi over 12 equals a over 4 plus b over 3. And I'm going to substitute this information in. So then that becomes pi over 4. And then we got pi over 2 over 3. And so then that would simplify into pi over 4 plus pi over 6. Okay? So, maybe if you decided to guess and check, you would have picked that first, and maybe you wouldn't have to go through the partial fraction method here. But the partial fraction method will work, and we got pi over 4 plus pi over 6. If you got a common denominator of 12, that would be 3 pi over 12 plus 2 pi over 12, and sure enough, that's 5 pi over 12. So we had to go through all that, and now we can just use the formulas. I know that's a lot to do just to get to the use of the formulas, but here we are. And so then we're saying that the sine of 5 pi over 12 is the same as the sine of pi over 4 plus pi over 6. And I'll try to run through these kind of quickly for you. So I'm going to just use the sum formula for sine. And so then we have sine of pi over 4 times cosine of pi over 6 plus cosine of pi over 4 times sine of pi over 6. Okay, we can evaluate those down to square root of 2 over 2 times the square root of 3 over 2 plus 1/2 times the square root of 2 over 2. And again, I'm just getting that off the coordinates from the unit circle at each of the pi over 4 and pi over 6's. Remember, cosine is x, sine is y. So then we have square root of 6 over 4 plus square root of 2 over 4. And, again, for me, I think it's really unnecessary to go farther than this, but you'll see in the back of the book they do factor things out. So just take a look and make sure that you're getting the right way. It's very easy to make a mistake when you get used to this, actually. There's probably a better chance that you make a mistake after you know what you're doing, simply because you'll look at the wrong part of the coordinate. So if your signs are all opposite, go ahead and check your work and make sure that you actually grab the right coordinate and you weren't going too fast. So cosine of 5 pi over 12 is the same as cosine of pi over 4 plus pi over 6. So then that means that the cosine of pi over 4 times the cosine of pi over 6 minus the sine of each of those multiplied together. Okay, so then right off of the unit circle, and that's even pretty good to leave it like that, but again, the back of the book is going to be a little bit different than that answer, but that is correct. And so finally, we're going to do the tangent one. And this one's going to be a little bit more to simplify here after we evaluate each of these. Tangent of pi over 4 is 1, plus the tangent of pi over 6 is radical 3 over 3, over 1 minus 1 times radical 3 over 3. And again, be careful. These are not, you can't cancel these into 1. They don't simplify that way. So we are going to have to rationalize the denominator. First, though, I'm going to actually get rid of our fractions by multiplying top and bottom by 3. And so then we would have 3 plus radical 3 and 3 minus radical 3. I'm going to multiply top and bottom by the conjugate, so 3 plus radical 3. Foil all that out, and I'll save you the pain of having to watch that. So then that becomes 9 plus 6 radical 3 plus 3 over 9 minus 3. So then that's 12 plus 6 radical 3 over 6, and then that gets down to that. Okay, so, that's the basics of the formulas in use, and that's all I'm asking you to do here for this first one. The next section is, I'll do a couple problems in the next section, just one or two. So I think I'm only going to do this problem. You're really just working backwards. It's, we're still working on the definition of these formulas, and so instead of starting over with this, we're starting with one of these, and this is section 21 to 30 there. So you're just really just matching these up, right? We got cosine, cosine, sine, sine, and we're being subtracted. So that looks like this one here. So really what we're doing is saying that all of this is equivalent to the cosine of pi over 7 plus pi over 5. We get a common denominator there. And add those together, and that's what they're asking you to do on this. For sure, just looking at this problem, you're not going to get the exact values of either of these because they don't show up on our unit circle either. But the practice is just to get you used to the formula. So then this would be cosine of 5 pi over 35 plus 7 pi over 35. And so then cosine of 12 pi over 35. Okay, and so this whole section you're just going backwards, just matching up the correct formula. So please ask if you got a question. Expect at least one more video on this section.